Hello everyone and welcome. In this lecture we will see how to represent a linear system in matrix form, especially in the form of Ax equals b. So if we have, for example, a linear system with m equations, we have like this one here. So we have here m equations and n unknowns. So if we have m equations with n unknowns, we can represent this matrix, linear system as Ax equals b, where this A here will be a matrix with m rows and n columns. So m here is the number of equations and n is the number of unknowns. So this matrix will be a matrix of these A's here, these constant A's here, so A1, 1, A1, 2. When we represent this A from this linear system here will be A equals the matrix A11, this A11 here, and this A12 till the A1n here, A1n, and this A21 here, A22 here, till A2n, and so on till AM1, AM2, and AMN. So this matrix will be matrix of m rows and n columns. And the vector x here is the vector of unknowns here. So the x1 is here, x1, and x2 is here, and xn here. So this column matrix or this vector will have n components because it equals the number of unknowns here, n, and the vector of the constant here, b. So b here will be equals b1, b2, bm. So the number here of components in the b vector equals the number of equations, and the number of unknowns equals the number of x here is equals the number of unknowns x, because x is the vector of unknowns. When we multiply this matrix A here by this vector x, we will get this left side here, and when this b will be this element here, or this constant here. For example, if we have a linear system of three equations, for example, x1 plus 2 x2 plus x3 equals 0, for example, and 2x1 plus, for example, here can be 0x2, for example, plus or minus x3, for example, equals 1, and 3x2 x1 here minus 4x2 plus 3x3 equals, for example, 4. So when we have this linear system, we can represent this as A equals 1, 2, 1, and 2, 0, minus 1, and 3 minus 4 plus 3, 3 minus 4 and 3. So this will be the matrix A, and when we multiply it by x here, for example, x will be, the vector x will be x equals x1, x2, and x3, and the vector b will be b equals here 0, 1, 4. Here the number in this example here, the number of m here is equals n. The number of unknowns equals the number of equations, but it can be, for example, if we put another, for example, equation here will be x1 plus 2 x2 plus 3 x3 equals, for example, 2. So this matrix will be here will be 1, 2, and 3, and the x will be the same x here because we have here just 3 unknowns, and the vector b will be 0, 1, 4, and with these 2 here. So as we write the linear system in the form of matrices, we can benefit from the matrix properties to solve this system, and especially when we have big number of equations, so the use of matrix will be useful and will make the procedure of finding solution for the linear system easier. And there are many methods to find the solutions of the system linear equations based on matrices. The most famous methods to solve ax equals b are the Gaussian elimination method and its variant Gauss-Jordan elimination, and also the LU decomposition, so LU decomposition of this matrix A, and the Cramer's rule also. And we will see all of them with examples in the next lectures.